Yes, good morning, good afternoon, good evening, ladies and gentlemen. I am Olwich. Uh, I'm here to respond to the call of a friend of mine who requested me to do a video on the design of beams using Tekla Trimble, and I'm just going to go direct with that. Uh, well, so if you haven't installed Tekla Trimble, I'm making an assumption that you already have Tekla Trimble with you, and so I'm just going to go directly to Tekla and start the design. Well, so the first thing I'll do is to launch the Tekla Trimble, and this is what you'll have. You have two options. You have to do TEDs, or you have to go for TEDs forward. And this is my option. I'll simply go for TEDs. I'll explain to you what all this mean, but not in this video, in a different video altogether, and the next day. For now, we want to go for Tekla TEDs. This one here, and this is the window which it will bring you to. Just give it some little minutes as it loads. Well, now, so this is the window which Tekla has brought us to. So we want to start a new design. We want to design our beam, and for you to start designing, well, you have to open a new project, because you need to start a new project because you want to start a new thing. It is not one which was already ongoing, right? So you actually want to start designing a new beam. Well, so for you to do that, actually I'm not intending to explain this entire ribbon. I'll do another video to explain this, but for you to design a new beam, simply go to Home tab, then press New, or simply go to File option here, click File and click New File, because we want to start a new project. After doing that, Tekla will bring you these options here, so you can choose which option you really want. You can see all the jobs which you can do using Tekla. You can design walls, you can design data calculations, you can design floors, you can design drainage, you can design columns, you can design beams, you can design, quite a number of things. So depending on what you want, you just go select there. Well, you can select directly here, let's say beams, and I'm assuming that you've already done your analysis, and so you just want to design that beam, right? And so I'm not going to select the one which will allow us to do the analysis. But then if you want to start it from scratch, you just have the loads, you want to apply the load so that the program will do analysis for you, simply select this option, beam, RC beam analysis and design. Depends with the code you're using. Tekla supports BS8110 and also the Eurocode 2 for beam design here. We also have, that is for RC beam design. Well, for this our case, we simply want to do beam design. That means we already have the loads which we want to apply. We already done the analysis, so we just want to input the moments and the shear so that Tekla can design for us that. So what you simply choose, come to RC beam design, just select RC beam design. You really need to notice that it is different from this, because this one is RC beam analysis and design, this one is RC beam design. Well, you can also just run a quick search here. If you don't see it here so quickly, you can just come here and type RC beam design, and it will bring you right to this one here. So let us go for RC beam design, that is BS8110 for this case. This is the preview. Tekla will show you this. Just press calculate because we want to start new calculation, and Tekla will open for you a new window where you will actually start your beam design. Just a few minutes. Well, it is there now. For this case, we have some default parameters which are here. I'm just going to go with these default parameters. I do not want to use any default any other different calculations, because this video is intended just to show how the process goes through. I'll do some other more detailed videos to show you different stuffs here and there in Tekla. For this case, let me just show you very quickly what this one is. Like in this case, you already have your moment. What is your design moment? I told you just at the beginning that I'm assuming that you've already done your analysis and you have your shear and moments which you want to design for. So just come here and put your bending moment there. We don't want to do redistribution, so just have that one as 0 moment distribution. I'll actually do a video to explain to you what the concept of redistribution is. For this video, I'm just going to keep that away for now. Then you can input the shear which you want to do here, the shear which you want to design for. Just input that in that checkbox. Then you can also specify the number of bars. You know, Tekla helps you to design in this manner. You know, design actually is an iterative process. What do I mean by that? You pick a section or you pick a rebar, then you check that rebar against the loads which you have, right? If the rebar fails, that means you have to increase the size of the rebar, or if the section fails, that means you need to increase the size of your section, right? Well, for this case, let us try a top reinforcement. You know, you really have to know how to decide whether you need a top reinforcement or you don't need a top reinforcement. This is from calculation. You need to get the value of K. From that you'll know whether you need compression reinforcement or not. Well, for this case, let's take the nominal is 2 bars. This is just for anchorage. 2 bars, 12 diameters. Then you can also you can see Tekla is saying no reinforcement required at the top, you know, because Tekla has done the calculations with these moments and shear, and it has determined that you really don't require any reinforcements on top. Well, for the bottom reinforcement, we can really we can try 16 here. Can try T16. You see what Tekla is telling you. Longitudinal reinforcement is too widely spaced, right? That means the space between these bars is not allowable. What do we do for that case? You can increase the number to 3 so that the spacing reduces there, right? So the space has reduced, so it passes. There's a tick here, and Tekla is telling you that area required is 539 square millimeters and area provided is this. That means you satisfy the rule that the area of steel required must be less than the area of steel provided. So actually this beam passes if you provide these bars with this section and all those other properties, then this beam passes. Well, you can actually come to beam details here. If you want to change anything in the section of the beam, you can change the section of this beam. Maybe let us go for 200 by 500. You can just input 200 there. Fire resistance, we just want 1 hour fire resistance. Fire resistance is a topic of a whole video, so let me just keep it at that for now. I'll do a video to explain the entire concept of fire design. Just keep it in this channel. You can subscribe so that you'll be notified wherever I'll post any video. Well, you can also specify your covers to reinforcement. Let me use 20 for side, bottom and top. The covers there. Then you also want to select your concrete class of concrete which you want to use. I'm using class 25 for this one. Density of reinforcement, density of concrete, sorry, is 2450 kilograms per cubic meter. Characteristic strength of reinforcement steel, characteristic strength of shear steel is that. then maximum aggregate size, is that after doing those settings you can say OK. Tekla will tell you whether your beam is failing or not. As you can see, the checks has been done and the beam passes. The area required is less than the area provided for bending. Then here also the T8s, these are the shear links, shear reinforcement. So Tekla has done the shear design, and Tekla has determined that we just need 244 millimeters squared per meter, and we have provided 335 millimeters squared per meter, so it passes. It can't fail by shear, it can't fail by bending. Then you can go to our output options. Do you want a full report? Output is basically how you want your report to be. Level of output, we want a full report. Do you want sketches? Of course yes, we want sketches to be in that report. Then say OK. After that you can simply finish. Then Tekla will take you to the report page. Yeah, so this is the report which Tekla has produced. You can see the parameters which you did input for calculations. Tekla has done other required calculations to determine whether your beam passes. I mean, this is the arrangement of the report according to Tekla. You see we have Tekla has done moment, design for moment, and the steel provided pass. Tekla has also done design for shear, and the steel area provided is sufficient. Tekla has also done other checks, the spacing of reinforcement, minimum distance between bars in tension, maximum distance between bars in tension, and all those. Well, the good thing with Tekla is that from this report you can really refer to the code, because Tekla tells you where exactly the formulas are coming from. If you check, for example, maximum distance between bars in tension, Tekla tells you that it is class 3 12 11 2 of BS 598110. Sorry. So if you go there, you'll simply find this formula. You can actually refer there and do some hand calcs to confirm whether it really agrees with what the software gives you. This is a familiar term, GIGO, which means garbage in, garbage out. So you have to do some quick hand calculations just for sanity checks, because you could have done a mistake and you don't know. So the moment you do quick hand calculations for 2 or 3 parameters and you see them going together with what you have here, then you realize that your calculation is okay. So this report, you can really take it to Word, you can really export it to Word. You can just click here. I'm not going to do that for now, just to keep the video short. You can just send it, and it will give you options of Word, Adobe, and all those. So you can send it there for purposes of presentation. If you want to really present it somewhere, you can actually save this report for future referencing. You just click the save option here. So ladies and gentlemen, I consider stopping there. If you have any questions regarding this, just put it in the comment section below. I'll try my best to respond to it. Otherwise, thank you so much. If you really want to see any such videos again, kindly do subscribe and like this video and hit the bell icon so that you'll be notified actually whenever I upload another video. For now, thank you so much. See you in my next